Let's have a look at this word problem. Find the mass of air and its weight in a living room with a 4 by 5 meter floor and a ceiling that is 3 meters high. For the rest of this word problem, I will leave that for you to contemplate. But I'm only going to solve this first part. I'm going to find the mass of the air in this room. Well, we need to draw a picture of the room so we have an understanding of what is being asked. And this room is 4 by 5. The floor being 4 by 5. Here's the floor. And we'll make this one here 4 meters by 5 meters. And it has a height of 3 meters high. So basically it's a volume. We're talking this rectangular room that looks like this. And the height 3 meters. And we're being asked to find the mass of the air that is contained within this room. And this is at 1 atmosphere. At 1 atmosphere, there isn't any air being pumped in or taken out. It's just regular room air. Let's have a look at our equation. The specific equation we're involved with is this one, where density is equal to mass divided by volume. Let's have a closer look at this equation. Density is represented by the symbol rho. The Greek letter rho is equal to mass divided by volume. And the mass, what we're concerned with is the mass of the particular fluid we are concerned with. In our case, it's air, so it's the mass of the air divided by the volume of the air. In our case, we're talking about the air that's in this room. And remember, air is a fluid. Air is a fluid. Let's put this, write this another way. Density is equal to mass divided by volume. And when I write volume, I don't want any misinterpretation with velocity. Sometimes I write velocity like this, other times I write velocity like that. But for volume, I will use, it's a capital V, and I will put a bar across it. This will designate volume. Capital V with a bar across. Rho is density, M is mass. If we have a look at the units of these now, rho is equal to, we'll look at the units on the right-hand side. Mass in base units has the units of a kilogram. Volume, as we know, is, if we multiply this, meters times meters times meters, it will be in cubic meters. So density has the units of kilograms per cubic meter. There is no other name for density for as far as units go. It's just kilograms per cubic meter using base units. Now let's go ahead and solve the problem. Now we have the equation. And it says find the mass of air and its weight. Well, let's find the mass of all of the air that's here. We're given some other information regarding the density of air. The density of air is 1.2 kilograms per cubic meter. So we know what the density is. We can calculate the volume of this room, and we just need to find the mass. So the volume of the room is equal to 5 times 4 times 3. Each one is in meters. Multiplying that out, it comes to 60 cubic meters. And the density of the air is given to us here, is equal to 1.2 kilograms per cubic meter. Putting in the numbers into our equation, 1.2 kilograms per cubic meter is the density of the air, is equal to the mass of the air, which is what we want to find, divided by the volume of the air, which we simply calculated here as 60 cubic meters. Now it's just a little bit of algebra. Up to this point, the physics is complete. All that's left to do now is a little bit of algebra. So we're going to isolate the mass, multiply both sides by 60. If I multiply this by 60 cubic meters, whatever I do to the right-hand side, I must do to the left-hand side. So multiply this by 60 cubic meters. And it will look like this when we're done. 60 cubic meters times 1.2 kilograms per cubic meter is equal to mass of the air. Those two will cancel out. Cubic meters and cubic meters will cancel out, leaving us with just kilograms. And that's a good thing because mass has the units of kilograms. Putting this in the calculator, the answer is 72 kilograms. So if I were to take the air in this room, bundle it all up together into a nice little ball, put it on a scale, it will weigh 72 kilograms. But still, 72 kilograms is in fact the mass. So what is the actual weight of 72 kilograms in metric system? Find weight of air. And we know from the past that weight is equal to mass times the acceleration due to gravity. We know the mass. We know what g is. We just simply calculate and define weight. Weight of the air is equal to 72 kilograms times 9.8 meters per second squared. And that comes to 5.6. And kilogram meters per second squared has the unit of a Newton. And weight is a force, and all forces have the unit of a Newton. Rounding this to significant figures, back in the original word problem, we have two significant figures, two sig figs. So we're going to round this to two significant figures. Weight of the air is approximately, rounding this going up 710 newtons. Or you can say that the weight of the air is 72 kilograms, but in fact, you were speaking about mass in this scenario, and this is the actual weight in newtons.